Lesson 8.4 for our online lesson today. We're mostly just going to be sharing information that's going to be helpful when we get together in class and work on some more problems dealing with linear programming. So this is going to be kind of a general description of some things that you can keep in mind while you're working on linear programming problems. I would suggest that you copy these notes down into your book so you have them to refer to when we're working through a problem in class. So first of all, an actual definition. Linear programming is just a mathematical process that has been developed to help management make decisions. And it has become a fairly widely and well-known tool in management science. A lot of these kinds of decisions can be made through computers now, but the computers still have to be programmed in a way that allows it to go through this process that we are doing by hand, which is called linear programming. So all of those steps that we talked about in our last class, that process is called linear programming. In linear programming, there are a couple of theorems that we can use that will make solving the problem a little bit easier. And the first one is called the fundamental theorem of linear programming. So again, if you remember the fundamental theorem of algebra when we're solving polynomials, it basically says however many solutions you will have to your polynomial equation depends on what the degree is. So it's one of those things where it sounds like it's this really earth-shattering theorem that's going to help you to understand everything there is to know about algebra, and yet it seems like a pretty simple theorem. Well, it's kind of the same thing here for our fundamental theorem of linear programming. You were starting to figure this out already during class, but here it is in actual black and white. And it says, if the optimal value of the objective function is in a linear programming problem, sorry, there's a typo there. So if an optimal value of the objective function in a linear programming problem exists, then that value must occur at one or more of the corner points of the feasible region. So you were starting to pick up on this as we were going through the problem in class, where we were setting a particular line of profit, and then we were sliding that line of profit to see kind of where would the last point be to give us the greatest amount of profit and still be within our feasible region. Well, regardless of where your line is going to be, there's going to be some final point that objective function line is going to touch. And that final point will be at one of the corners. So the shortcut to finding your optimal solution is to actually find your corner points and then test each one of those to see which one optimizes your function, whether you're maximizing or minimizing, which one accomplishes what you want to accomplish. Now, a word of caution here, not all linear programming problems have an optimal solution. And we'll talk a little bit more about that when we get to problems in class. But just keep that in mind, that not every linear programming problem will actually have a solution to it. A second theorem has to do with the existence of optimal solutions. So again, our theorem said if an optimal value for the objective function exists, sometimes it doesn't. And so how do we know when we should expect an optimal solution and when we should expect there not to be one? So there's 3 points under this theorem. The first point is if the feasible region for a linear programming problem is bounded, then both the max value and the minimum value of the objective function always exists. So a bounded feasible region is the easiest one to solve and to figure out, because you know you will always have a maximum value and a minimum value that you can find. Okay, second point, if the feasible region is unbounded and the coefficients of the objective function are positive, then the minimum value will exist, but the maximum will not. Okay, we've seen some examples of that where we might have our graph and we'll have maybe a couple lines that go like this, but this is the part that is shaded. Okay, so it's easy to see where maybe a certain line here, that this would be the minimum point that it would hit, but there is no point going out this way for a maximum point. So we should be able to find a minimum value in this kind of situation, but we will not be able to find a maximum value. Okay, so again, we need to keep that in mind and know what kind of a feasible region we're talking about in the first place to know what we can expect for optimal solutions. And then the third point in our theorem is that if the feasible region is empty, then that would mean that there are no points that satisfy all the constraints. So if you are drawing out your system of inequalities, and as you're looking at the parts that should be shaded, you realize there's no particular region where all of the shading overlaps, then that means your feasible region is empty, and that means that both the max and the min value do not exist, which should make sense. If there's no feasible region in the first place, then there's no corners to test, there would be no max or min points. And that can happen sometimes where the constraints don't actually allow you to produce anything that matches everything. So again, keep that in mind, that if that ever happens in your problem, then you just know automatically there's no max, there's no min, there's no optimal solution that you can find. So that's really all there is for this online lesson. It's just information that's going to be helpful as we continue to work with linear programming problems during the next class. If you need to, go back, rewind, make sure you get all of this information down in your notes so it will be easy to refer back to it as we're going through the problems in class. And that's it for today, so we will see you next class.